of your life, you have always thought that a neutron was the smallest you could go. Today you know. A neutron is really an up quark, a down quark, and a down quark. Your brain should be like exploding right now. This is cool. So today's lesson is about the introduction to the basic, the most fundamental understanding that we have of matter. And what's really unique about today's class is that they're learning about leptons and hadrons, and in particular, very specific type of lepton, which is a neutrino. The electron neutrino, the muon neutrino, the tau neutrino. These are our leptons. So getting to go to the South Pole and participate as a researcher for a month gave me insight into the skills that scientists are using in the field in real time. Hi guys, Miss Miller here. I am at the ICL, or the Ice Cube Lab, here at the South Pole. Let me show you what it's like here. So there is the Ice Cube Lab from the outside. For a little bit of perspective, over here, that tiny building on the horizon right there, that's the South Pole Station. That's where we came from. For teachers, having experiences outside the classroom is really invaluable. We're trying to prepare our students for the real world, and so I need to know what the real world of science is.
So when you have a teacher who has real world experience with what you're learning, it just makes it more interesting and entertaining.
You can tell Miss Miller, doing the things she did, that this is real physics, like this is like current physics that's being done right now.
Right now we're studying particle physics, and so she's been able to take what she learned in Antarctica about neutrinos and tell it to us and help us incorporate that into our learning.
Now what's kind of cool is the reason I went to Antarctica was to study the neutrino. And here we see the neutrino showing up in the lepton category. Now, the Ice Cube project undergoes a lot of different filters in order to get down to that neutrino, to convince us that we're actually detecting a neutrino. Today, I think students are getting a sense of just how unique neutrinos are. Since they're chargeless and nearly massless, they're really hard to detect, so it makes the South Pole experience even cooler. So right here, this line of electron neutrino, muon neutrino, and tau neutrino, that's what Ice Cube is doing. This is like cutting edge, super current research that we are trying to learn more about right now. We do not have all the answers yet.
Something that surprised me quite a bit is sort of the purpose of the experiment itself. I knew they were sort of detecting neutrinos, but I didn't really know what for. But apparently they're sort of using it as a very strange form of telescope to sort of observe celestial objects, which I thought was pretty neat, honestly.
Her having first-hand experience with it can help us understand it more. We can apply it to real-world stuff. Because when you think about particle physics, it's just we're not scientists. We don't have the equipment to look at it in detail. But she's been there. She's seen all of it, so she can relay that information directly to us.
Students, you should recognize this as the DOM, one of the light detectors that normally sits in the ice itself. The South Pole is not the only place that you can study these, but it makes for a pretty ideal location. For one, it has a lot of a really, really clear substance. So the ice, when you get really deep at the South Pole, is super clear, clearer than the glass in your glasses. And so what we're actually detecting is the light that's coming from this neutrino interaction. And so you want to make sure that that light doesn't bend or take weird turns, so you need a really, really clear substance. Another reason, of course, we could be anywhere in Antarctica, but the South Pole has some place for us to eat and get warm and sleep, so the support is already set up there as well. Finally, we use the Earth at the South Pole as a filter, so if a neutrino comes through the North Pole, pretty much only neutrinos can make it all the way through the Earth and then come out the South Pole. So it's a pretty unique place, super remote location, but it was an awesome experience.
Just having a teacher that had that whole experience, it really shows how much passion she has for the stuff we're learning and just science in general. And so as students, we're able to feel that same passion, and it really has an impact on the classroom and the environment.